Hello everyone, I'm nabina and we are here for the presentation of the supply chain management. So our topic is where is supply chain organization currently investing and planning to invest for the digital supply chain. So these are our contents. So starting from the introduction, let us talk about the supply chain. Supply chain. So what is the supply chain? It is the system by which the organization source, make, and deliver their product and the service according to their market demand. Its main goal, its operation and the decision is triggered by the demand signal that is like a customer level that depends on the customer level, and its main goal is to increase the revenue and for the better asset utilization and the cost reduction. So even though it has so many benefits, there are also some challenges like the forecasting and the demand planning, maintaining the expected service level with the customers, inventory planning, and the finding the quality supply at a good price, and optimizing the supply chain structure and the interfaces. And similarly, it has a high logical cost as well. So so there is a urge for the upgrades in the supply chain management, and it is not other than it is the digital supply chain. And what is the digital supply chain? It is simply a collaborative digital environment that integrates the numerous technology, activity, outputs, and the supply chain flows. And the digital supply chain models have a strong network and a collaborative partnership across the entire supply chain. It is more faster, more accurate, more flexible, more granular, and more efficient. Talking about the trends, about 75% think that it is very important, and 70% have already started the digital supply chain transformation. In about 5 years, 95% expect more processes with the suppliers to be automated. And similarly, 94% expect to receive more real-time status updates for the supply chains. Well, traditional supply chain must involve interconnected, smart, and highly efficient supply chain ecosystem with the layers to address the customer solution and the digital operations. And it empowers themselves to proactively manage and efficiently fulfill the customer needs across the multiple channels quickly, identifying the changes in the demands and organizing their supply chain accordingly. In this way, they can turn their supply chains into the real competitive advantage and use it as an enabler for the new digital business models. And it provides the benefits like the cost-effective revenue enhancement and the business agility. So nowadays, many companies are investing in the different digital technologies like the talent supply chains, mobility, information supply chain, cloud, social media, physical supply chains, big data, and the financial supply chains. And for the further information about the investing sector, I would like to call the Muna for the further presentation.
Thank you, Navina. I'll be further talking and discussing about the big data and cloud computing, the investing sector of supply chain management. So, briefly introducing about the big data. What is big data? Big data is a set of data that are analyzed and visualized in the easy interface and that are related to the human understanding and that provides a clear picture in any sort of business process. What is cloud computing? Cloud computing is a kind of a network. It is a cloud network that are controlled by one of the remote server host, and that remote server host processes, manages other local server and the personal computer. Next slide, please. Discussing about the characteristics of big data, there are 5 Vs. There are volume, velocity, value, variability, veracity, and verity. Volume. If big data is a pyramid, volume acts as the base of that pyramid. Volume usually includes the characteristics of big data in any kind of sizes, and it stores any type of sizes, either it's in terabytes, it records them in a systematic way. The velocity. Velocity mainly refers to the speed of the data. Less is the data, more is the speed, more is the speed of its analyze, more is its speed, and it is analyzed in the real time basis. Value includes the statistical characteristics, which includes the correlations and hypothetical and other different kind of mathematical calculations. Similarly, variability is any kind of changes in the data are systematically managed, and it poses the characteristics of veracity, which includes trustworthiness, that covers the security, and accountability if the data are lost in between. Verity usually covers the characteristic of big data, whether the set of data are structured or the unstructured, it are stored systematically in the set of big data. Next slide, please. I'll be further discussing about the analytical tool that are used by the big data implementation in process in supply management. There are various analytical tools that are Master Database Management System, MDMS, MapReduce, Hadoop. In that three, I'll be discussing any two, that is MDMS and MapReduce. So Master Database Management System covers a big volume of data. It stores filters and retrieve the value data that are added into its system. It provides a much centralized cluster of metadatabase system as well. Talking about the MapReduce, it is a simple, general, but most powerful programming tool that are used for a large scale computer system, for the large number of clusters of a commercial personal computer to achieve automatic parallel. It combines all the intermediate values related to the same key and transmit them to the reduce function. Also, the MapReduce compresses the value set into a smaller set. So further moving towards the another slide. So I'll be covering further about the cloud supply chain in logistics sector using a Keyforce cloud computing services in 5 stages. It is the overall process of integrated supply management process. In the first stage, it it starts by the production schedules, which are sent to the supplier in the form of cloud interface. In this step 2, supplier receives a schedules update its business process as well as build the schedule. In step 3, the shipment notifications are sent to the manufacturer via cloud interface. And in step 4, receiving and scanning of the product are carried out by matching the ship notice. Finally, in the step 5, the financial process occurs, which is the cash payment that are documented, and it occurs bank to bank. Next slide, please. So the findings of cloud computing and cloud computing and the big data combinedly is the cloud computing is analytics that provides the solution for the storage and the processing of the big data that can be related to the big data. But the primary goal of a cloud computing system is to use the voluminous computing and storage resources under a concentrated operational management in order to provide a big data applications with a various computing capacity. Next slide, please. For this slide, I'd like to call Ranjita.
Thank you, Mana. I'm Ranjita Rao. I'd like to start with digital supply chain transformation towards blockchain integration. So first of all, blockchain is a distributed digital ledger which can transform the supply chain. Ultimately, it can increase efficiency and transparency. As we all know that blockchain and IoT is related. Blockchain technology can be used in tracking billions of connected devices. It can also deliver more transparency and increased accuracy of supply chain due to diligence information. And also one more thing of blockchain is that it empowers IoT devices so to enhance security in IoT ecosystem. And it also enables end-to-end tracking in supply chain organization by the use of radio frequency identification RFID. Next slide, please. Thank you. This is a figure. We can see this supply chain, and the other is blockchain based supply chain. So simply, supply chain is the flow of goods and services, which includes all the processes that transforms raw materials into final products. And the process includes the raw material supply, manufacturer, distributors, wholesalers, retailers, and and the other is blockchain based supply chain. In this figure, as you can see, there are four major entities play roles, that are registrars, standard organizations, certifiers, and actors, and actors includes manufacturers, retailers, and suppliers. There is smart contracts stored in blockchain, which define network actor interaction amongst each other and within the system. There are lots of benefits with blockchain-based supply chain. Ultimately, organizations can save time, money, and efforts. Also, there is smart devices connected with IoT in blockchain-based supply chain, which as a result help to generate more profit in an organization. Next slide, please. This is about real-time analytics in supply chain management. There are huge importance of real-time in today's globally connected supply chain, and real-time information gathering allows planner to analyze and distribute the data in a cross-organizational way to promote better organization. Also, supply chain analytics can help a business better predict the future demand of an organization. This BI system, which can analyze the information that can enhance operational efficiency and key performance indicator in an organization. Also, supply chain analytics can be used for strategic decision. It also improves manufacturing efficiency, upgrades management, and increases delivery. Next slide, please. Okay, for further slide, I would like to call Benjil. Thank you.
Thank you, Ranjita. Hi, everyone. My name is Benjil and I will be covering the case study part. This is an Australian case study on an early detection system for proactive management of raw milk quality. This case study talks about an idea of a smart farm, which is basically an enhanced version of traditional farms, as they use real-time data to provide farmers with value-added benefits. This has led farmers to gain valuable insights in a timely manner, leading them to efficiently exploit their available resources. Next slide, please. This has led farmers to gain valuable insights in a timely manner, leading them to efficiently exploit their available resources and increase both the quantity and quality of milk produced. The idea of smart farm includes use of RFID tags to monitor milking process, use of robotic milkers, use of IoT platforms to monitor cows' health, detection of disease using real-time monitoring using nanosensors and biosensors, use of nanoscale digestive aids to increase feeding efficiency, calving alert, and birth monitoring using temperature and pH sensors, developing a milk yield prediction and analysis tool. Next slide, please. Every stakeholder in a dairy supply chain has to satisfy the quality requirements in order for the whole chain to achieve its highest value. We can see in the given figure that the dairy supply chain includes farmers, processors, retailers, transporters, and end users. The problem in the case scenario are the very common supply chain issues. In the dairy chain, different metrics are used in the literature to quantify and represent milk quality. For example, some approaches measure milk quality in terms of its nutritional value, such as fat and protein, while some measure milk quality as the presence or absence of diseases in the milk. Dairy products with high quality standards and extended shelf life are recently in demand. Talking about extended shelf life, so how do we do that? Basically, we will have to slow down the bacteria growth in the milk. This is done by controlling the temperature of the milk. The temperature of the raw milk needs to be in accordance to the food standards, Australia, New Zealand's guidelines. This temperature has to be maintained while transporting the milk as well. There are several temperature testings done that includes temperature testing by transporters upon arriving at the farm before transferring milk from storage tank to the truck and after the milk is picked up and taken to the processor. This shows that there is no testing in between these events. Basically, the level of bacteria in the milk determines the quality of the milk. And the reactive approach suggests throwing away the milk that does not match the quality. Thus, there is a need for a proactive approach to manage the quality of raw milk. So I will talk about the proactive approach in the next slide. Rather than measuring the bacterial index, which represents the quality of the milk as a composite measure, we need to monitor and manage the building blocks which lead to the bacterial index. It is proposed that there needs an online monitoring of different key factors that impact bacterial quality, which are the temperature and the time the milk is stored at that temperature. This will present a comprehensive picture of the milk quality from the first point of entering the tank to the end point of leaving the tank on the farm. This can benefit all members of the supply chain, such as it can benefit the farmers. The collection schedule of the transporter varies from being daily to alternate days, depending on the optimal milk collection routes between farmer and processor. Between any two pickups, farmers store the extended raw milk in tanks, as shown in the figure here. As there is no segregation in a tank's milk, raw milk which is milked at different times is mixed and stored. This implies that the rate of change in bacterial quality of the tank's milk is not in accordance with the freshness of each batch of the milk, but according to the overall quality of the milk in the tank. On the other hand, if a proactive approach to manage milk is used, it will then assist farmers to make smart predictive decisions towards maximizing the milk quality and achieving the maximum economic benefit from it. Now, this can benefit the transporters as well. Being proactive in managing the milk quality will not only assist the farmers, but also the transporters in avoiding scenarios where milk is rejected by processors and ensuring that further bullwhip effects such as milk storage and loss in revenue downstream in dairy supply chain is avoided. Now, this can benefit the processors. So if the processor is provided with high quality raw milk, it not only increases the processor's flexibility and efficiency in producing high quality alternative dairy products, but also reduces the milk rejection in the processing plant. Next slide, please. So now I will be talking about the digitalization in supply chain in this case. So the case further focuses on proactive approach to managing the quality of raw milk by adopting a data-driven approach and using online monitoring to analyze the impacts of key factors for milk quality. A tank installation kit is used. So this tank installation kit guarantees that milk of high quality reaches the next steps in the supply chain and consequently provides the processor with a maximum milk life, not only allowing more flexibility for handling raw milk and increasing efficiencies, but reduces the risk of raw milk reaching bacterial level of concern. The second one is installing an early warning or early detection system using IoT devices and systems. This will allow the user to monitor and detect the milk temperature exceeding the standards, and it generates alarms for the farmer of risky situation and recommends predictive actions to be taken. Next slide, please. So now I will talk about the conceptual framework for an early warning system. As shown in the figure, the prerequisites for developing an early warning system requires capturing data and knowledge from two sources. Data in form of critical information related to milk quality captured from installed sensors in the tank, knowledge captured from the domain expert relating to the milk's status in the tank and converted to a form required for modeling the system. The system will help notify the experts of the quality of raw milk and any predictive actions needed. Next slide, please. So now jumping right into the conclusions, the focus is more on a reactive approach of evaluating the quality based on the bacterial index and preventing milk with a high bacterial index from moving further downstream in a dairy supply chain. An early detection system by using IoT data to automatically determine the events in a milking cycle with high accuracy is developed. An early warning system using the present early detection system for proactive management of milk quality is also proposed. Thus, we can overall conclude that the digitalization in a dairy supply chain is thus beneficial to all the stakeholders in the supply chain. Thank you. So the presentation has come to an end, and these are some of the references that we use to complete the presentation. Thank you.